Okay, so I'm going to start with square roots, and I'm going to start extremely basic because then it will be so much easier to understand the rest of it. Okay, so if we have, let's start with the square root, whoops, this pen might be dying, of 25. If it has a square root of 25, there's a shelf here, and that's just an invisible 2. So it's basically saying what times itself can give us 25. Well, I know that 5 times 5 gives us 25, so then the square root of 25 is just 5. Okay, now we know those we can go through because sometimes we just have those memorized. But the reason why this worked is because we're going to make a factor tree. So we're going to look at 25, and we're going to say what times something. It doesn't have to be itself, but we know that 5 and 5 are prime, so then they can't go any further, so then we circle it. And then we have to find buddies of 2. So 1, 2, and since there were 2, I say that this is jail. And this is a jail, and you have to have a buddy to help break you out of jail. So here's a pair of 2, so then 1, 5 gets to come out. And then I tell my kids too, like, one of the guys had to sacrifice his life for his friend because there's 2, it takes 2, but only 1 comes out alive. Okay, so let's try another one. Let's try square root of 18. So since there's no number here, it's still an invisible 2. So then I'm going to go through and I'm going to say, okay, well, I know that 6 times 3 is 18. So I could have started with 2 times 9. It doesn't matter what you start with. Just try and get numbers, but you don't want 1 times 18 because then that's not going to get you anywhere. So you want numbers other than 1. If only 1 can go into it, it's prime, and it couldn't go any further. Okay, so 3 is prime, meaning that only 1 times 3 will get us 3. Okay, 6, I know that that's 2 times 3. So those are prime. 2 can only be 1 times 2. Okay, so there's a 2 here, so I need buddies of 2. So here's 1, 2, 3s. But 1 has to sacrifice his life for the other, so only 1 3 gets to come out. And 2 doesn't have any like gang members. He's the only 2, so he's still stuck in jail. So 3 square root of 2. Okay, now if I wanted to, I could have rewrote these. This has an invisible 1. If there's no exponent, it just means 1, right? So here, it's just saying 25 to the 1/2. That's how you rewrite it. That's how you'd always rewrite these. So if I had, let's just try an example. Let's say I have the 4th root of 7 cubed. To rewrite that, it's just 7 to the 3 and then 4ths. That's just how you rewrite those. So this has an invisible 1, so this could say 18 to the 1/2. And so on. So it's that same pattern. Let's try one more of these. If you were to have let's go backwards actually. Let's say 5 to the 2/3. Okay, so let's look back at our pattern here. So the 4 is the denominator. So I say this guy is always the bottom guy because like they're gang members and they're the lowest of low. That's what I told my kids. So to tell us how many gang members, that's the bottom of the fraction. So he's the low guy. And this is the honest guys who are inside jail. So he's the top. So 7 to the 3/4. Okay, so the top guy is still in jail. So 5 to the 2nd. That guy's telling us how many gang members we need to get out. So he's outside of the jail. Okay, now if we were to keep on going further, then if it's 5 squared, that means that this is just 5 times 5. And if you look here, we have 1, 2 5s, and 5s are prime, so they can't go further. And we need groups of 3, but there's only 2. So then that's as simplified as we can get. Okay, let's try another one. Let me look at your problems really fast to see how intense they get. Oh, there's some negatives. Okay. So let's try 9 to the 2/3. Okay, so we're going to rewrite 9 to the 2/3. So the bottom guy is the low of low, so he's outside of jail, and it's 9 to the second. So I'm going to rewrite 2 9s. So 9 and 9. If it said 9 to the 5th, then you just write 9 5 times. And then you'd break apart all of those. Okay, and then 9 is not prime, so we have to keep on going. We know that 3 times 3 gives us 9, and 3 is prime. So just to list off some prime numbers, it would be 2, 3, not 4 because 2 times 2, 5, 7, 11, 13, 17, 19, 23, and then other than that, you're really not going to go any higher than that. Your teacher's not going to go that high. Definitely not even close to that, but I'm just trying to give you an example of all primes. Okay, so I need groups of 3. So I have 1, 2, 3, 3. So 2 guys sacrificed that. It's going to take 3 guys for 1 guy to come out. So 1 guy gets to come out, the other 2 sacrifice their lives. That guy doesn't have 2 other gang members to help him out. So 1, 3 is still stuck inside. Okay, let's try one more of those, and then I'm going to do some negatives. Actually, yeah. Okay, let me think. Sorry, I'm just trying to think on my toes. Let's say 4 to the 5 halves. So that guy goes outside. And even though it's invisible, I always write 2 there. But really, if we didn't write a 2 there, it'd just be understood that a 2 was there. Okay, so I'm going to rewrite 4 5 times. 4 times 4 times 4 times 4. And then all of these can break down to 2 times 2, which 2 is prime. Sorry, I'm running out of room. So these are all prime 2's. And we need groups of 2. So 1, 2 can come out. And then you multiply all the ones that can come out. Another 2 can come out. And remember, it takes 2 gang members for 1 to come out. Another set of gang members makes 1 more come out. And the last set of gang members allows 1 more to come out. So then we multiply our answer. So 2 times 2 is 4, times 2 is 8, times 2 is 16. And that's our answer. And if we had some guys that were stuck inside, then that means that, like, let's say that we only had 1, 2 that didn't have a gang member, then we would just write 2. But let's say that I had a 2 and a 5 that were left over out here. So let's say I had a 2 and a 5, for example. Okay, so that would mean that that doesn't have a buddy and that doesn't have a buddy. So then we'd multiply those and write square root of 2 times 5 is 10. So it'd be square root of 10, so 16 root 10. But this doesn't have that, but just as an example if it did. Okay, let me do one of these on here. So let's try, I'm going to do number 41 to start off. So number 41, actually I'm going to do 42 because you might have odd answers in the back of your book. So that way this will help you with more. So 3x to the 1/2 to the 4th. Okay, so 3 to the 4th would be, I don't have a calculator, so 3 times 3 is 9. Sorry, I'm using my fingers. Times 3 again is 27. 27 times 3 is 81. Okay, and then, so it was 3 to the 4th, and then 1/2 to the 4th, which if there's a parentheses there, we multiply them. So 1 times 4 is 4, divided by 2, or 4/2 is 2. So we're going to have x squared. And this doesn't have any radicals, so then we can't go any further. I'm going to go back up to a negative on number 32. Let's go back to that really quick. So 24 to the negative 3/4. If you'll remember back to negative exponents, if something has a negative exponent, all that means is that it's going to go down to the bottom of a fraction. So now we're going to have 24 to the 3/4 here, and there will be an invisible 1 or just 1 there. Actually, it can't be invisible because it's the top. Okay, and then let's make that a radical. So 4th root of 24 3 times. So I'm just going to write 24 times 24 times 24. All over 1. Okay, 24, I know that that's 2 times 12, so I'm just going to write 2 times 12 on all of these. And 2's are prime. Okay, 12 can go further. I know 2 times 6. 2 is prime. 2 times 6. 2 times 6. And I know that 6 is 2 times 3. Okay, so we got to find groups of 4. So 1, 2, 3, 4. Okay, 1, 2 can come out of the bottom. Okay, 1, 2, 3, 4. Another 2 can come out of the bottom. And then I have 1, 2, 3 3's that are still stuck inside. So 4th root of 1, 2, 3. So 3 times 3 times 3 is 27. And then 2 times 2 is 4, so it's going to be 1 over 4. 4th root of 27. That's your answer. Oops, didn't realize it was off that. Okay, let me see. I'm gonna have to stop this video and make another one because this is running too long.